All right, this is a review on functional notation, how that kind of works with quadratic functions, and just some additional skills I feel like in this section we need to be talking about. So this first set is just asking us to determine the following. So f of 0. Now, when you have your quadratic already in standard form, f of 0 is going to be your c value. And again, by standard form, I'm referencing this as standard form. I know that the OpenStax textbook says that that's general form. I've always known that as standard form. So when I'm saying standard form, I'm saying this. So f of 0 is -3. If I put a 0 here and here, I'm only going to be left with -3. All right, let's talk about 2. And I specifically had a -1 here because I want us to make sure we know it's negative, and then you're plugging in 2 for x. So imagine as if a is equal to -1 in the front. It's not a negative x inside the x squared. And then plus 4 times 2 minus 3. So this is going to be -4 plus 8 minus 3, which gives me 1. If I want to find f of -3, I am again going to have -1 here on the outside. I'm going to plug in -3 inside the squared, plus 4 times -3, and then minus 3 on the end. That's going to give me -9 minus 12 minus 3. Ooh, a very negative number, -24. Now comes in a new concept that you may or may not have seen before, but I want to start developing plugging in function values that aren't necessarily integers or even real numbers. So if I were to tell you to find me f of a, well, that's the same thing as f of x, just everywhere you see an x, you're going to put in an a. So that's going to be -a squared plus 4a minus 3. Now this is a different a than our standard form a. Just make sure that you understand that. It is the variable a that you're plugging in instead of x. Well, what if I ask you to plug in a plus h? I'm going to do that the exact same way that I did any of these over here when I was plugging in an integer number or one of our counting numbers. So negative, and then in place of x, I'm going to plug a plus h squared, plus 4. In place of x, I'm going to plug in a plus h, and then minus 3. Just like I did with the numbers here, I'm going to square a plus h first. I'm going to have a -1 still on the outside, a squared plus 2ah plus h squared is that expansion. I'm going to distribute 4 and subtract 3. Last thing I'm going to do is distribute this negative. So I would get -a squared minus 2ah minus h squared plus 4a plus 4h minus 3. None of those are like terms. And if you're like, why the heck are we doing this? It is a basis for our calculus difference or difference quotient. Yes, sorry, I lost my train of thought there. And if you're like, I'm not in calculus yet, we need to be using function notation, okay, now, so that those concepts get a little bit easier when we are in that course. Okay, so if you think about what is f of a plus h that I'm plugging in for, I solved for that right here. So I'm going to plug in this whole thing where I see that f of a plus h. So I'm going to write a big fraction. I'm going to plug in -a squared minus 2ah minus h squared minus 4a plus 4h minus 3. All of that gets plugged in for f of a plus h. I also found f of a right here, right? So I'm going to say minus f of a. So negative a squared plus 4a. I'm going to run out of room here, minus 3. And then I'm going to divide that by h. So again, just to color code it here, this piece is f of a plus h minus this piece in my parentheses that ran off the page there is f of a. Let's go ahead and distribute this negative. And when I do that, notice I'm going to get positive a squared minus 4a so this should be a plus right here. And then minus negative 3, right? So plus 3. Notice that any of my terms that don't have an h end up canceling, which is why I knew I missed that negative, okay? So negative a squared and a squared cancel. 4a and negative 4a cancel. Negative 3 and 3 cancel. Let's write what's left over. Negative 2ah minus h squared plus 4h all over h. If I factor out an h, I'm left with negative 2a minus h plus 4 all over h. These h's will cancel, and this ends up being my final answer. We'll practice this more. It's new. You might need to watch that a second time. But I personally like to, again, introduce this to you early so that when you see it in calculus, it's not the first time, and it goes along really well with function notation. On part B here, it's asking for what values will f of x be 0? So that's the same thing as asking, like, find the solutions, right? Negative x squared plus 4x minus 3 equal to 0. Let's factor out a negative 1. And then I need two numbers that multiply to 3 and add to negative 4. That's going to be negative 1 and negative 3. Since a inside is now a positive 1, I still have that negative 1 here on the outside, but x minus 1, x minus 3 must be my two factors, which means my zeros happen at 1 and at 3. If I want to figure out where my function's equal to 1, then I'm going to let me change my color just because it's right next to it so we don't get confused. Negative x squared plus 4x minus 3 be equal to 1. Remember, we solve all quadratics by moving this over and setting that quadratic equal to 0. Same process. I'm going to factor out the negative. And then I am only going to have one number that multiplies to positive 4 and adds to negative 4. And that's when x is equal to negative 2, right? So notice I still have two solutions overall, but really it's only when x equals 2 that I end up having an output of 1. Well, what does that mean? Because quadratics are symmetric, right? That means that my vertex must be at the point 2, 1. Because I didn't end up having two spots where this quadratic was equal to this output. So I have a quadratic that opens down because a is negative. And then when I tried to figure out, well, when is it equal to 1? There was only one x in which that happened. So this must have a vertex at 2, 1, and then open down. And if you do any of the vertex formulas, I bet you find that that's true. All right, I also wanted to pull back in some piecewise functions for us to talk about. So let's go ahead and graph each one of these, and then I'm going to erase the pieces that we don't need. So I say that my outputs are 2, and so let's go ahead and draw that in. Now I do think when I go to erase, it's going to erase the whole thing, but let's just see. Okay, but I only want that for x less than 2, right? So I'm going to go ahead and put an open spot right there, and then let me see if it will let me erase. No, but I can just go back and just plug it in like that. Okay. All right, let's go ahead and graph y equals negative x next. So y equals negative x. Would go like that, right? Okay, I know that when x equals negative 2, that's going to be filled in. So let's go to negative 2. Oh, and look, so that hole that I originally had gets filled in right there. And then when x equals 2, I'm not equal. So I'm going to do a little open piece. And then let's see if I can erase. Okay, I'll just go back in and draw it. Okay. All right, and then our last one is x squared minus 4. Okay, so x squared moved down 4. I would go over 1, up 1, over 2, up 4, and then draw in my quadratic function that way, right? Okay, when x is equal to 2, I have a closed end piece here. So I know that that's a 0 actually of that graph. And then I actually only want this part of that quadratic graph. So let's go ahead and erase the other part. And so that's my piecewise function graph. All right, we have one more example to look at here. We have a parking structure that is adjacent to a road, and we're going to put fencing around it. But because it has the road, we only have like 2 widths, right? And then 1 length right here. And we have 340 feet of fencing. So let's first figure out the amounts of fencing in terms of x and y. So I would have x plus x, right? So 2 x's plus 1 y must end up being equal to 340. It says to solve this for y, so I'm going to say y equals 340 minus 2x. Let the area be determined by a times x. Well, yes, that makes perfect sense, right? We're going to substitute in y into this area equation, so the area is just a function of x. So area is equal to x times y, but in place of y, I'm going to plug that in. And so I'm going to get 340x minus 2x squared, or minus 2x squared plus 340x. Find the maximum area of that the fencing will allow. Well, I'm going to find the maximum of this. This is a quadratic that opens down, right? A is negative, so let's find the vertex. That's going to be at x equals negative b over 2a. That's going to give me a negative over a negative is a positive. 340 divided by 4, 85. So when x is 85, I'm going to have maximum area of this parking lot. Well, when x is 85, y is then 340 minus 2 times 85. And that ends up being 170. And so the maximum area would be x times y. And so this area is max at 85 times 170, oh my goodness, which is 14,450.